So for today's learning target, the idea of graphing stories, that's what we're focusing on for today, is graphing stories. It's the idea of being able to read a scenario and relate it to a function, a relation of some sort. So what we're going to be doing through here is we're given a series of different kinds of relations that are graphed in representation of time and temperature. Okay, so how temperature relates to time, or how the time relates to the temperature. And we're trying to map out the information that's given to us so that we can identify which one of these, graphs represents the story that's been presented to us. And this is actually going to get us introduced into a project that you can work with a partner if you wish. It will be due when you come back from Thanksgiving break. I'm giving you that long to work on it, even though previous years I've only given like 4 days for them, because it's not that difficult of a project. But I'm giving you an extended amount of time if you're wanting to work more on the creative aspect, especially if you are planning to work with a partner. Just keep in mind that when you're working with a partner, it does have to be hand done, not on the computer. You are having to create these by hand, and you're going to have to make sure that you go that much more into detail because you have more than one mind working with you. Is that understood? Okay, so, and we'll explain more about it. I'll have that part of our presentation for today, what the graphing stories are going to look like. And I think for some of you, you guys are going to like them because it does take a lot of creativity and it kind of ties into language arts. So, all right, so for here, this problem, we have the air. The air temperature was constant for several hours at the start of the day. Then the temperature rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. So a lot of these key terms that we're hearing here are representing movement throughout the graph, the movement that's existing on the vertical as well as the horizontal. So we're going to start with the very first part. The very first part says that the temperature, the air temperature, was constant for several hours at the start of the day. What does constant mean? What kind of visual representation do you think a constant temperature would mean? Do you think it goes up, it goes down, it stays flat? Maybe it goes up quickly, maybe it goes up slowly. What does constant represent? David? It stays the same. When we're talking about it being constant, we're talking about a value, a measurement. Richard, it's a step now. It's 3 times. Turn around. When we're talking about constant, we're talking about it staying consistent, staying the same temperature for several hours. So when we're looking at graph A showcases a constant. It's a flat horizontal line at the start of the graph. So does graph B. Graph B is showcasing a constant. Graph C, I can automatically eliminate from my grouping because of the fact that it does not have a constant that it's starting with. So we can automatically eliminate C from the running. Okay, the next thing that we're going to go ahead and take a look at then, the second line. It says the temperature rose steadily for several hours. Rose steadily for several hours. Okay, so rose steadily. Rose is another way of saying that it increased, right? It goes up. Both graphs happen to showcase that they are having a steady increase. One may be a little bit more steeper than another. That's okay. They both rose steadily. When we get to part 3, the third line, it stayed the same temperature for most of the day. Stays the same temperature for most of the day. So again, if it stays the same, it's another representation of it being constant. Only graph B is showing that you're going to have a constant temperature or staying the same in the center. If we're looking here at graph A right here, it does not match up because it immediately starts to dip back down. So graph A is not going to be a part of our representation. That means the story maps up to graph B. If we finish off the rest of the story talks about how at the end it's going to drop sharply at sundown. If we're looking at this drop, it's a pretty steep and quick drop. Not exactly vertical. Okay, it's not exactly vertical because vertical drop would mean that it goes from this temperature to this temperature with no time changing. That's not possible. There has to be some time that's changing or elapsing for there to be a change. Okay, so it does show a sharp drop. That's how you do graphing stories. You're matching up each sentence structure to a graphical change. Okay, some of the problems you are mapping it from a story to a graph. Some of them you're going to be looking at a graph and creating the map. So go ahead and flip on over to the back of your page. Oh, actually, let me write a couple side notes here, just so that you have them down. So some of those key terms that we talked about. When we talked about it being constant, so I want you guys to understand, if you see something that says it's a constant, then that means it's a nice flat line. That represents a constant. If you see things that say like rose steadily, when we see the terms rose steadily, that's going to be a straight vertical incline. Again, when we saw the terms stay the same, that is another flat horizontal line. And then, of course, when we see a sharp drop or dropping sharply, that's a vertical straight down almost. Okay, very steep, a steep decline. Okay, so go ahead and get those written down and then flip on over to the back of your page. I want you guys to go ahead and do problem 2 on your own. I want you to identify key phrases in here and then map them to each part of the graph until you identify which graph represents that situation. Okay, let's focus on the very first setup here. A person starts walking, gradually speeds up to a run, but then slows back down to a jog, right? So they start walking. They start off by walking. So what do you think walking represents? What is that going to look like, Fatima? A constant, right? So walking, that's going to represent a constant speed, isn't it? So we're looking for a flat line, a nice flat line. Does graph A have a flat line? No, there is no flat line for there. What about for graph B? Does that have a flat line? Yeah, graph B has a nice flat line. That's going to work out. Now, graph C does not have a flat line, but hold on, let's start off, and you start walking though. If you're starting to walk, when you start walking, are you at the same speed? I'm going to retract that for a second. Are you at the same speed the minute you start walking? No, because when you start walking, what's happening? You're speeding up, right? You go from not moving at all to starting to move, don't you? So actually, we're going to change that. It's not going to be a constant. You're actually going to show a nice little increase, aren't you? Okay, so really B says that from the very moment that you're standing still till you start walking, you're already at a top speed. That's not possible. So we're actually going to cross that off. I apologize. We'll see. Let's see which graph you're going with. Shh. But But that's a good, I'm glad that you made that mistake, and I'm glad that I went along with that mistake too. So that is a perfect mistake that people can make, that you think automatically that you're starting off at a constant. I thought the same thing, but when you really think about it, you can't start at 0 seconds to automatically already being at a high speed. Okay, you have to work your way up to it. Yeah.
And it also wouldn't work because he starts with...
Yeah, if we start looking at the rest of the graph won't work with what they're saying. Yeah. All right, let's take a look at the rest of it. You're going to gradually speed up to a run. So actually that's going to continue going, isn't it? Gradually speeding up to a run. So this whole thing is going to have us gradually speeding up. Okay, starting at 0, we're going to walk, and then we're going to gradually speed up to getting to a run. Both A and C are showing that. Then you're going to slow back down to a slow jog. So that portion right there shows that there should be a decline, right? Does A show a decline? No. A shows just a flat line, so that's not going to work. Okay, but C shows a small decline that's going to happen until we get to a slower pace where we're just going to jog along. So there's going to be our correct answer. And what Zach was saying, he says B wouldn't work. He says because, yeah, we eventually go up and then we're going to go down, but then it shows that we're going back up again. At any point does it say that we're going to go back up again?
No.
No. So he had the right notion with that as well, that B is not going to work in that sense either. So C should be the correct answer. Go ahead and flip on over to the third page, or your second page, which is our third problems. Taking a look here, what we're going to do is we are going to create a story to match the graph that's here. Everybody is going to have a different story. All of your stories are going to be slightly different. But what your story is supposed to showcase is that at the very beginning of our time frame, our water level is at what? 0. Then it's showing some sort of increase. Then it's showing a consistency here, a constant. And then it's showing a quicker decrease than there was an increase until we're back down to 0. You are going to come up with a situation, a story that reflects this information. I'm going to give you about 2 minutes to think of a story, and then I'll present to you one that I've got. Okay, so let me share with you a story that I've got here. So, I'm going to say Bob. We'll just say Bob. I'm going to start off with my pink. Bob fills a pool with water. Or maybe he fills a tub with water, but he's filling something up with water. Bob fills, we'll say a tub with water. Okay, so when he's filling it up, when you're filling the tub up or filling the water up, it is at a steady pace. Okay, so at a steady rate. That represents this portion right here. He is filling up the water at a steady rate. Okay, then over the next period of time, so I'm seeing here at this point, it's staying constant, isn't it? So, when the tub is full, he takes a bath. Okay, so he's in the bathtub for a little while, doing whatever he needs to get done. Then, we're seeing a quicker drop here. Water drains at a faster rate than what it fills up. When he is done, he drains the tub. Shh, guys. He drains it. He unplugs the tub's little stopper, drains down. Or if it's a pool, maybe you drain the pool, okay? So either way, we're showcasing that the water's filling up, then the water stays consistent, the water's getting drained out, okay? We're actually going to, do you need me to do another example? No. You guys okay? I want you guys to go ahead then. You have loaded into Google Classroom. You've got a quizzes that you are going to work on.
I'm so excited.
Hold on.